All right, so good greetings to all of you. This is this is Math 102. And the course is about some analytic geometry and calculus. So in this particular session, what I'm going to do is I'll talk about the coordinate geometry aspect, which is dealing with the lines. So this I call it coordinate geometry 1, which deals with lines. So a line, or if we have points on a line, we can identify these points with real numbers and many other types of numbers that form a coordinate line. Of course, if we have a plane, then you can also have points on a plane and you can identify them by ordered pair of numbers to form a Cartesian plane. So by that, I mean that if you have a point, then on the Cartesian plane, if you have a point, then you can identify this with an ordered pair AB, where A is the X coordinate and then B is the Y coordinate. So if you have a point here, okay, let's say A, and then you have another point B, which is also in the Cartesian plane. If you join these 2 points, or you can find some of the things you can do, you can find the distance between these 2 points. So the first thing we talk about is the distance between 2 points. And the distance between 2 points is if you have a point A, okay, if you have a point A, which is x1, y1, this point here, and you have a point B, which is x2, y2, the distance between these 2 points, you derive it by forming a right angle triangle. So you create another point, which is 90 degrees from A and from B as well, and this we call it a C. So if your A is x1, y1, and your B is x2, y2, then your C is x2, y1. The distance AB is nothing but just using the idea of the Pythagoras theorem. Okay, so you do a Pythagoras theorem. So the Pythagoras says that the distance here, this is the distance AB squared is nothing but the sum of the distance AC and BC. So if you do that, you see that if you take the distance AC, you have x2 minus y2, x1 minus x2 minus x1 squared, plus the distance BC, you have y2 minus y1 squared. So the distance AB is the square root of the sum of squares of x2 minus x1 and y2 minus y1. So, example, if you have 2 points, P, which is -1 and -2, and A, which is 3 and 5, then the distance between these 2 points, you calculate it using the formula we just described. So it's the sum of the square root of the sum of squares along the x-axis and then along the y-axis. So if you take the x-axis here, you have this as x1, and then you have here as x2. So you find the difference in this on the x-axis in these variables, and then also you sum them square, and then you sum also along the y-axis. So you take the y1 and then you take the y2. Then if you find that this gives you the distance between these 2 points A and B. So if you have 2 points, example, if you have 2 points A and B, if you have a point A and then you have another point B, and you draw a line to them, then this is a line. Then what we want to do next is to find the midpoint between 2 points. Okay, so the midpoint between 2 points means you are halfway on the x-axis, you are halfway, and on the y-axis, you also are halfway on the y-axis. So if you again have 2 points, A, which is x1, y1, B, which is x2, y2, then the midpoint, if you put a point M, which is you label it as xy, and you call this, you refer to this as the midpoint, then we know that it creates, we can create some triangles here, I and I here, okay? So along the x-axis, we see that A, the distance AP should be the same as the distance MQ, which is along the x-axis. And then along the y-axis, the distance PM should be the same as the distance QB. And this is what we mean by it is a midpoint. That is what we mean. So if we take the x-axis along the x-axis, for instance, then we say that the distance AP is equal to the distance MQ. So the distance AP means that the y variables are the same, that y here and the y here are the same. So you find the difference in the x. So here it is x minus 1, x minus x1. And then MQ as well, you see that you have the same y, so you find the difference x2 minus x. Once you do that, you just do then some algebraic manipulation. That means that you can do, once you have x minus x1, x2 minus x, then you can take your x on the right-hand side to the left-hand side to give you a plus, and then your x1 from the left-hand side to the right-hand side to give you a plus. And this is what gives us 2x is equal to x2 plus x1. And this gives x to be half of the sum of x2 and x1. Then along the y coordinates, what we have as well is a similar thing. You have the distance PM is equal to the distance QB. So you find the difference along the y-axis. So this is y minus y1. And then also for the QB, you have y2 minus y. And then you take the y to the left-hand side, and you take y1 to the right-hand side. And once you do that, you'll be able to solve. You have 2y is equal to y2 plus y1. And this finally gives us our y, which is half of y2 plus y1. So this gives us the y value for the midpoint. And then we've also computed the x value for the midpoint. And so this midpoint is nothing but half of the x1 plus x2, and then half of y1 plus y2. So an example is that if we take an example where we want to show that P, Q, R, and S is a parallelogram, we know that for a parallelogram, then since the midpoint along the diagonal, okay, the diagonals, the midpoint of the diagonals should intersect, right? So it means that the midpoint of P, okay, the midpoint of P and R, and then the midpoint of S and Q should be the same. And we check. So we find the midpoint of PR is nothing but half of P and R, right? So you take the x-axis, which is half of 1 plus 5, and then the y-axis, half of 2 plus 9. And this should be the same as Q and S, the midpoint of Q and S, which means half of 2 plus 4 and half of 7 plus 4. And truly, this gives us 3 and 11 over 2. Okay. And the next property we want to talk about is of a line is the gradient of a line. So the gradient of a line, if you have a line, then we know that the gradient of a line is usually a change in y over the change in x. This is what we know as the gradient of a line. So the change in y is nothing else but y2. If you draw your line A and B, which is A is x1, y1, B is x2, y2, then the change in y is y2 minus y1, then the change in x is x2 minus x1. And this gives you the gradient of your line AB. Okay. Of course, we have a connection of trig identities as well with the gradient, right? We know from the trig identities that the tan theta, right, is nothing but the opposite over the hypotenuse, the opposite over the adjacent, okay? The opposite over the adjacent. And then if we look at it as well, we see that if you have an angle of inclination theta, then tan theta is the opposite, which is the distance CB, right? So the distance BC over adjacent, which is the distance AC. This gives us tan theta. And this is exactly the same as the gradient of AB. So the gradient of the line is connected to the angle of inclination the line makes, okay, with the x-axis as well. Then some information that if we have two lines, okay, that are parallel, if we have two lines that are parallel, then the gradients of these two lines are the same, equal. Okay. So if you have M1 and M2 for line M1 and L2, then we say that M1 is equal to L2. And then if we have perpendicular lines means that the line 1 makes a 90-degree angle with the line 2. If you have such lines, then we say that the product of their gradient, right, is equal to -1. Product of the gradients of perpendicular lines gives us -1. The next, we talk about the equation of a line. So if you have a point, if you have a point B, okay, if you have a point B which is given by x, y, or if you have a point A given by x1, y1, and this which goes through a line with gradient m, then the equation of the line is given by, because we know that the gradient of this line between the point x1, y1 and b, xy, the gradient is the change in x and the change in y over the change in x. So if you take these two values, then the gradient is y minus y1, x minus x1. And with that, you will be able to write down the equation of a line. Of course, in some cases, you see the equation of a line also written as mx plus c, which is the general form in this setting, when x1 and y1 are 0. Okay. So example, we find the equation of a line through the point A, which is 1, 3, and has a gradient 5. So if you write your gradient, which is 5, is equal to now your change of the point y from 3 and then x from 1, you'll be able to then do a change in subject substitution and then you'll be able to derive finally your y is equal to 5x minus 2. Then the next thing we'll talk about is angle between two lines. So if you have a line L and another line such that L2 makes an angle beta of the x-axis and L1 makes an angle alpha and lambda of the x-axis as well. And then L1 and L2 makes two angles between them, theta and then 180 minus theta. Of course, if you take the triangle being formed, which is in this case I, then you see that theta plus lambda plus beta is equal to 180. And with that, you're able to show that lambda is equal to 180 minus alpha because the angle beta and alpha. And then lambda is as well equal to 180 minus beta plus theta. Of course, it's also because here we know that lambda plus alpha is also equal to 180. So with these two knowledge of the relationship between these angles, you say that 180 minus alpha is equal to 180 minus beta plus theta, where your theta is now alpha minus beta. So with that, you say that your tan theta, which is now equal to tan alpha minus beta, and we use the properties, the trig identities of tan alpha minus beta, which is tan alpha minus tan beta over 1 plus tan alpha times tan beta. But the angles or the gradient of line 1, we assume in this case that the gradient of line 1 is greater than the gradient of line 2. And so what we do is that we have now an M1, which corresponds to the line 1, right? Line 1 has gradient M1, line 2 has gradient M2. So we have finally M1 minus M2 over 1 plus the product of the gradients. Then if you take the other angle, which is 180 minus theta, because using the trig identities, you have tan 180 minus tan theta over 1 plus tan 180 tan theta. And this is nothing else but negative tan theta. Okay? Because tan 180 is 0. Example, find the angle between two lines, y is equal to 2x plus 1 and y is equal to 3x plus 3 plus 2. We know from these two lines that there are gradients. For this one, we have the gradient to be 2, and then for that one, for this other line, the gradient is 3. So we do it such that we always choose the one with the biggest gradient first. The angle these make is that now you have tan theta is equal to M1 minus M2 over 1 plus M1 times M2, which is the formula we just proved. So you just make your substitutions, which is 3 minus 2 over 1 times 3 times 2, which is 1 over 6 is equal to 1 over 7. Then now to find the angle, you need to find the arctan, which is the tan inverse of 1 over 3, which is 8.13 degrees, which gives us the answer. That is the angle between the two lines. And the next one, we talk about the division of line segments into given ratios. So earlier on, we spoke about division the midpoints, which is also the division of the lines aligned, but now into equal ratios. But we want to generalize this idea to a case where we do not have to have equal ratios, but we can have any type of ratio. So for midpoint, we know that you have to be halfway through it. But now we want to talk about cases where maybe you are not halfway through it, or you can be also be here, any proportion at all. So this is the idea that we deal with in this case. So first, we deal with the internal. So the same proof ideas that we use for the midpoint. If you have a ratio n and m that divides your line, and then you have r to be the points in between A and B, then we know that you have two similar triangles such that you have this triangle, you have triangle 1, and then you have triangle 2. And then for on the x-axis, again, we say that the distance AC should be the same again as the distance RD. So, and this should be proportional to the ratio that we have, which is the N and M. And if we do that, then we see that the distance AC is nothing but X minus X1, and the distance RD is also nothing but X2 minus X is equal to N over M. Then you do a change in subject. Okay, so if you don't know how to do it, this is usually the idea. You take your M up, and then you take your X2 minus X to the other side. Then when you do that, you simplify them, and you get X to be mx1 plus nx2 over m plus n. And then similarly on the y-axis, you have drc proportional to b, d is equal to n to m, which is rc, the drc over dbd is equal to n over m. And then again, you do your algebraic manipulations. You take this here, that here, you multiply through, you get your y, and this becomes the points of any ratio internally dividing line segment AB. Then we have external division. So for external division, of course, it means that we have AB, AX1, Y1, BX2, Y2, and then we have a point which is outside of the extent of the line segment, but also in the proportion or in the ratio n, and then the other ratio of m. If you do that, then similar ideas, you have a triangle, one, and a bigger one, and a triangle 2. So RAC and then RBD. So if you do that, also, then you see that the distance RC and the distance RD are in a ratio n to m. So you also do your algebraic manipulation and then the change of subjects, and you'll be able to derive x to be n x2 minus mx1 n minus m. But this you can also write it as mx1 minus n x2 over m minus n. And on the y-axis, you also find the same trick on the y-axis. For the distance AC is proportional, it's in a ratio, it's a proportion of the distance BD. And then this is y1 minus y over y2 minus y is equal to n over m. And then you again do algebraic manipulation. Then you have m multiplying y1 minus y, n multiplying y2 minus y. And if you do your manipulations, you'll be able to write finally y to be ny2 minus my1 over n minus m, which is also the same as writing it as my1 minus ny2 over m minus n. And this is what we have here. So we do a simple example. Find a point dividing the line, joining the point A, which is 1, 2, and B, which is 3, 1, internally and externally in a ratio 1 to 2. So internally, we know the formula that if you internally, there is a sum. So you have mx1 plus nx2 over m plus n, and then my1 plus ny2 over m plus n. And then we know from here, this is your x1, this is your y1, this is your x2, this is your y2. And then this gives you 5 over 3 and 5 over 3. Externally, we have already derived the formula as well. But now you see it's mx1 plus n minus nx2. So it's a minus. Okay. And then if you make your substitution, you should get minus 1 and 3.